Hello everyone, this is Dr. E, and for today we're going to be working on a special type of parallelogram, which is trapezoid, and we're going to be using its theorem to solve for the missing parts of our trapezoid in this lesson. In geometry, we have different types of quadrilaterals, and we also have different types of parallelograms. And for this particular lesson, we're going to be diving into some problems involving a special case of parallelogram called trapezoid. And for this particular lesson, we're going to be working on the theorems on special trapezoids and some of the differences in the trapezoids that we are working on in this lesson. So let's start with the trapezoid, or this special parallelogram called trapezoid. So according to the definition, a trapezoid has a parallel side, so opposite sides will be parallel, and at the same time we have special parts of trapezoids that we're going to be familiarizing ourselves with so that we'll be able to understand each other using the language of geometry. So let's have this trapezoid so that we'll be able to understand the definition of trapezoid a little better. So the basis that we are talking here are the parallel sides of our parallelogram, which happens to be the top and the bottom horizontal lines that you are seeing in our trapezoid right here. And these parallel line is special because the name that we're going to be calling this pair of parallel sides would be our basis for our trapezoid. So for our trapezoid, we have two bases, the top base and the bottom base. And the two sides that we're seeing right now are called the legs of our trapezoid, and they're not necessarily congruent with each other as long as we have one set of parallel lines in our quadrilateral. That would be considered as a trapezoid. And another parts of trapezoid that we're going to be using would be the base angles. So we call this base angle. So we have two pairs of base angles, the top pair and the bottom pairs, and both of them in geometry are called base angles. And when you hear this word in some word problems involving geometry, know that you are talking about the corners of your trapezoids, specifically for the top base and the bottom base. So let's have this second type of trapezoid, which is called isosceles trapezoid. And we know that isosceles triangles are triangles with same sides, or the sides or two sides of our triangles are equal. When it comes to trapezoid, we also have such a thing as an isosceles trapezoid, so that means our bases are parallel, and at the same time, our legs are congruent. So when this happens, this special type of trapezoid is now called isosceles. So we have a regular trapezoid and we have an isosceles trapezoid that you will be seeing in our work for today. So let's talk about the theorems that we're going to be using so that it will help us answer problems involving isosceles trapezoids and regular trapezoids. And for this particular theorem with isosceles trapezoid TRAP, if the base angles or the base angles of our isosceles trapezoid will be considered to be congruent. So that means RA have the same measurement and TP also have the same measurement because we are seeing an isosceles trapezoid. So that means given that ABCD, trapezoid ABCD is, you are seeing isosceles, we can say that if the measurement of angle A is 80 degrees, the measurement of angle D is also 80 degrees. And in a problem, given that we have an isosceles trapezoid and we know that angle C is 100 degrees, if we're asked to find the measurement of angle B, we know using this theorem that angle B is also equal to 100 degrees. And we know in a polygon, if we have four-sided polygon, the sum of the interior angles of a four-sided polygon is equal to 360 degrees. And it's also true in this isosceles trapezoid that we are using to highlight this theorem. So the second theorem in an isosceles trapezoid is that if we have trapezoid TRAP, which happens to have a congruent angle. So not necessarily an isosceles trapezoid. However, using this theorem, we can conclude that this particular trapezoid can also be considered isosceles because their sides will be automatically congruent as long as your base angle, one of the base angles, would be congruent to each other, which means if we have trapezoid ABCD, which happens to have congruent angles at 80 degrees. So with this given information, we know that if we have side AB, which happens to be 16.2 centimeters, if that information is given to us, if we are asked to find the measurement of side CD without even doing algebra, we know that CD is also equal to 16.2 centimeters. So this is the second theorem about trapezoid, and our third theorem would be on the basis of its diagonals. So if we have an isosceles trapezoid, our diagonals BD and diagonals AC are considered to be congruent, which means given that this trapezoid right here, we have AC, let's say 10 centimeters, and BD, which is also 10 centimeters, if we measure those lengths, we know that AC will have the same measurement as CD because they are isosceles trapezoid, and that is what theorem number 3 is telling us. So how are we going to use these three properties or theorems about isosceles trapezoids that would help us with our problems like with trapezoid CDEF? Let's see if we can find the measurement of angle D, angle E, and angle F, given that angle C is 65 degrees, using the theorems that we have learned in geometry. Now, in this particular case, since we know that this is an isosceles trapezoid with a given angle C at 65 degrees, we need to figure out how to find DEEF. And in this case, I'm going to extend line DE and CF so that we'll be able to use our popular theorem or lesson on parallel lines cut by transversal, because this time I will consider line CD, which is one of the sides of our trapezoids, to be our transversal. And why am I using this theorem? Because I know that I am able to produce the same side interior angles in this particular parallel lines cut by a transversal, and they are considered to be supplementary. And that is going to help me in solving for measurement of angle D, because I know that angle C and angle D are supplementary because they are same side interior angles in a parallel lines cut by a transversal. So angle C, if I add it up to angle D, I know that it's going to be equal to 180 degrees because they are supplementary. And in this particular problem, I know that angle C is 65 degrees, and I'm looking for angle D, and I'll be able to do that or solve this using algebra by subtracting 65 on both sides, so that I will have angle D by itself, and then I'm going to find the value or the measurement of angle D by subtracting 180 and 65, which is equal to 115 degrees. So now that I have angle D, which is 115 degrees, now I'm ready to find the rest of the corners of my isosceles trapezoid, and I'm going to solve it without using algebra, but with this theorem about isosceles trapezoid, that their base angles are congruent. So if we have angle R and angle A, they are congruent because they are isosceles according to this theorem, and angle T and angle P is also congruent. So using this theorem to this trapezoid CDEF, then I know that angle E is also 115 degrees because their base angles are congruent. So now I know what my measurement of angle E is, and I would also know my measurement of angle F, I can use my 360-degree theorem for a quadrilateral, or I'll just use this theorem, which is base angles of our isosceles trapezoids are congruent, so angle F is also 65 degrees. And this is how we use the theorems and some of the lessons that we did before in solving the missing parts of our trapezoids. So for your challenge, your number bender challenge of the day is that I'm going to give you an isosceles trapezoid PQRS, and you are given angle R, and your task is to find angle M, or angle P, angle Q, and angle S using the properties and theorems that we have learned from this lesson. So comment it down below and let's see how you're going to find the values of those missing parts. So this is our lesson for today on a special type of quadrilateral, specifically a parallelogram, which is the trapezoids. And we know that there are two types of trapezoid. You can have an isosceles trapezoid or just a regular trapezoid. And the three theorems that we have used in solving some of the trapezoids that we've worked on in this lesson. So in working with trapezoids, just practice, and I'm sure that you'll be able to remember those theorems without knowing it, because if you use it, you'll be able to acquire the skills on working with geometry problems similar to this one. This is Dr. E, and see you again next time. Bye!